Okay, let's go into our third step then, which is our coagulation cascade. So we've had our see here, we've had our platelet plug formation. So all these platelets have been wrapped around this von Willebrand factor, and they've joined together, which we know with the GP. Sorry, let me just write this down. We've got our GP 2B/2A receptors, so that's between our platelets, and our GP1B receptors between our von Willebrand factor and our platelets. Okay, so that's formed our little thing there, our plug. We've now got this negative sort of charge around, or these receptors around our platelet plug, okay? And this is what initiates our coagulation cascade to start, our intrinsic pathway to start. So this is the trigger for our intrinsic pathway, okay? Not to confuse with our extrinsic pathway. So our intrinsic pathway is triggered by this platelet plug formation. So we know, back to our classical model, that factor 12, once it's triggered, it becomes factor 12A. Okay, factor 12A, that initiates factor 11 to become factor 11A. Factor 11A, that triggers factor 9 to become 9A. Now factor 9A, this needs calcium and vitamin K to be able to join itself to our von Willebrand factor and our collagen, sorry. Okay, so although I've drawn this as it's getting further away from the clot, in reality, this 9A will be attracted to our collagen. So that's what attracts it back to the site of our injury. So we want this 9A to be near here, so that our next step happens near here. So wherever we see this red writing, that's it being drawn back in to our site of injury. Okay, so our 9A, it binds with calcium and vitamin K, and it also forms a complex with factor 8. So that's our factor 9A8 complex. Okay, so once that's formed, that initiates factor 10. So this is now in our common pathway. Our factor 10 now becomes factor 10A. Again, this needs potassium, not potassium, sorry, I put K, vitamin K and calcium to bind it back to our collagen, to make it more attracted to our collagen. If you remember our polypeptide, our carboxyl group from our potassium, and our calcium from our binds to the carboxyl. So we've got that positive charge attracted to our negatively charged collagen. So our 10A, that binds with our factor 5 to form another complex, and that activates our prothrombin. So prothrombin is factor 2. So once we've got this 10A5 factor complex, that triggers our 2 to become 2A, which is thrombin. So our thrombin, again, this needs our vitamin K and calcium to bind it back into our collagen, and that triggers our fibrinogen, which is soluble. That's factor 1. So factor 1 is soluble, and this is fibrinogen. It turns into factor 1A, which is fibrin, and this is insoluble. So it's like a jelly-like substance. So if you think of clotted blood, it's jelly-like. We want it to be insoluble so that it clots our blood. Okay, so we've got our fibrin, we've got our end product really, but we just got this one further step. So our factor 13A, so our activated factor 13. So 13 is activated at the same time as fibrinogen. It happens at the same time. So we've now got active 13, and this triggers our fibrin to form cross-links. So our fibrin is now cross-linked, and we see here we've got this cross-bridging of fibrin. Okay, so that's important because it can now coat our platelets and form this clot that holds it in place and prevents it from floating away, okay, which is not ideal. Okay, so that's our intrinsic pathway leading to our common pathway, but we've also got another way in which our common pathway can be triggered. So that's via our extrinsic pathway. So this happens when tissue factor, so that's produced by damaged tissue, this enters our blood, okay? And this tissue factor, so it's factor 3, this comes into the bloodstream. Our free floating, so factor 7, this is floating around in our blood, and when it bumps into tissue factor, or factor 3, it gets activated to form factor 7A. Okay, so our active factor 7A is triggered by factor 3 or tissue factor essentially. So this again, it needs vitamin K and calcium to bind to our collagen. And then we've now got two routes it can take. It can either go and trigger our factor 9 to become 9A. So that's in our intrinsic pathway. It can trigger this, this cascade, or it can just skip that and go straight to factor 10 and trigger the common pathway just directly. Okay, so there's two ways it can do that, and again we have the same outcome. We have the fibrin mesh, which is what it's all about, and that is essentially the coagulation cascade. It forms this sort of mesh on top of the platelets, keeping it in place and stopping more blood from leaving. Okay.